Thanks for joining me today. Do you ever have to write numbers that are just so long and you're looking for a way to shorten them? Well, that is why we write numbers sometimes in scientific notation. Let me show you how. We are going to start off with the number 68,000. And I know that number is not very big, but I'm just going to use it right now to show you how to put a number in scientific notation. So the first thing you want to do is you want to make this number's value in between 1 and 10. So you want to make it a number less than 10 and greater than 1. So we would need to put our decimal right here to make that number in between 1 and 10, because now the value of that number is 6.8. Okay, the next thing you're going to do is rewrite that number. And since we have zeros on the right side of the decimal, those don't really mean anything, so I'm not going to write them, okay? The next thing you're going to do is you're going to think, how many times would I multiply 6.8 times 10 to get back to the original number? An easy way to see how many times you would need to multiply by 10 is to just take this decimal and see how many times it moves to the right to get to the end of your number. So this decimal would need to move 1, 2, 3, 4 times to the right. So that means we would need to take the number 6.8 and multiply it by 10 4 times. So that little 4 is going to go right here. This is called an exponent. This means 4 groups of 10. So we would take our 6.8 and we multiply it by 10 4 times. So this is how you write 68,000 in scientific notation. Let's do another one. Here we have the number 153 million. So, like I said last time, the first thing you want to do is think, where would you want to put a decimal to make this number's value in between 1 and 10? So, we would want to put our decimal right here, because 1 and 53 hundredths, or 1.53, is a number larger than 1 but less than 10. Okay? You always want to have a whole number on the left side of your decimal, and then usually that number will be in between 1 and 10. Okay? So we're going to rewrite that new number, 1.53, or 1 and 53 hundredths, and then we're going to think, how many times would we have to multiply by 10 to get back to the original number? So I'm going to count my digits, because every time you multiply by 10, this decimal could move 1 spot to the right. So 1, 2, 3, 4, 5, 6, 7, 8. So we would have to multiply by 10 8 times. Remember, that is called an exponent, and that is how many groups of that number. So this is the answer of how to write 153 million in scientific notation. Let's do another one. Okay, here is the number 400. So think really quick, where would you want to put the decimal to make this number in between 1 and 10? Did you say right after the 4? If you did, that's correct. We are going to rewrite this number. I'm not going to put a decimal here and put zeros off, because this number also represents 4.00. I could just write 4, okay? Now I'm going to think, how many times would I have to multiply 4 by 10 to get back to the original number? So I'm going to count my decimals, 1, 2. I would have to multiply by 10 twice. And if you think about it, 10 times 10 is 100, and then 100 times 4 would bring us back to that 400. Let's keep going. Here is our next number, the numbers 5 and 26 hundredths. Now, this number is quite small, and normally you would never be asked to put this in scientific notation, but I'm going to show you how just in case. So, as you notice, this number 5.26 is already in between 1 and 10. So I'm just going to rewrite it real quick. 5 and 26 hundredths. And then I'm going to think, how many times would I have to multiply by 10 to get it back to the original number? Well, I wouldn't have to multiply it by 10 at all. So I'm actually going to put a 0 here. And just so you know, anything to the 0 power, like this, 10 to the 0 power, that answer is just 1. Okay, so this is kind of like saying 5.26 times 1. Now, like I said, you probably won't be asked to do this, but you might see it every once in a while. Okay, let's just do a couple more. All right, here we have the number 28 hundred thousandths, or 0.0028. So this is the first example where our original number is actually really, really tiny. All the ones that we did earlier, they were larger numbers. So I want you to do the same thing. I want you to think, where would I put a decimal in this number to make its value in between 1 and 10? Okay, you should have thought right here. So this number is going to become 2.8. And instead of asking myself how many times would I have to multiply by 10 to get back to the original number, I'm actually going to ask myself, how many times would I divide by 10 to get back to the original number? So when we divide by 10, we get to move our decimal to the left. So I'm going to count the units left until I get to my original decimal. 1, 2, 3, 4. Now, when you divide by 10, that can actually be written like this, -4. This negative in the exponent there, that actually means divided by. So this is how you would write this teeny tiny number in scientific notation. Let's practice a couple more like that. Here is our next number, 7 millionths. So first things first, I want to put that decimal in a different spot so the value of my number is between 1 and 10. So if you think about it, I should put my decimal right here because then the value would be 7. 7 with the decimal after it means 7. Think of $7. $7 would be written 7.00. which also just means 7. So I'm going to rewrite that number, and then I'm going to think, how many times would I divide by 10 to get back to the original? And I would divide 1, 2, 3, 4, 5, 6. I would have to divide by 10 6 times. So that means my exponent up here is going to be negative, because this whole thing together times 10 to the negative 6th power actually means divided by 10 6 times. I know this is very new and it doesn't make a ton of sense, but this is math language. Let's do one more example. Here is our last problem, and I want you to just think, where would you put the decimal to make the value of this number in between 1 and 10? If you guessed right after the 6, you are correct. So I'm going to rewrite this number with the decimal in that spot. And I can't forget about the 4 and the 1 out there. We do not drop those off because they're not zeros, okay? Then I want you to think, how many times would I divide by 10 to get back to the original? And we would divide 1, 2 times. And that's where this -2 is going to come from. So I know this was a lot of information at once, but if you could just remember, a negative exponent up there actually means divide, okay? Let me know if you have any questions. Otherwise, don't forget to click subscribe and have a great rest of your day.